Greetings and welcome back. Today we'll be talking about alkane nomenclature. So nomenclature, or how to name these molecules, can be applied to any functional group, and we've learned about a lot of the different functional groups already. But today we'll be starting at the basics, starting at naming alkanes. So as you may recall, alkanes are molecules that are strictly hydrocarbons, that is to say they only include carbon and hydrogens, and there are no double bonds or triple bonds or rings or anything like that. But as we'll find, all of the naming that we'll do is going to build on itself, but everything comes back to alkanes. So you need to be able to name alkanes perfectly in order to be able to name an alcohol or an ester or anything like that. So the nomenclature that I'm going to teach you is the internationally used IUPAC nomenclature. IUPAC is the International Union of Pure and Applied Chemistry. It is an international body that in the 70s came up with a systematic way of naming all organic molecules, and that is what we will learn and what we will use. So the big picture way of naming a molecule, any organic molecule, is to find the main chain of the molecule, name that, and then name whatever groups are coming off of it. So for instance, on the previous slide, I drew a very simple molecule that looks like this. And the first step of naming is to find the longest carbon chain with the highest priority functional group attached. But in terms of alkanes, it's always just the longest chain, since there are no functional groups attached. So what we need to do is locate the longest continuous carbon chain. And in this case, it's quite simple. It would be these 6 carbons in a row right here. And you could count them out from left to right or right to left. It's the same way. 1, 2, 3, 4, 5, 6. There would be a couple other ways to identify a chain here. So for instance, we could go from the left to the bottom. That would be a 4-carbon chain. Or we could go from the bottom to the right, and this would be a continuous 5-carbon chain. All right, those two on the bottom are simply wrong. We would never do this, and we would never do this. What we need to do is locate first the longest carbon chain. All right, so in order, the carbon chains are 1 carbon, which would just be CH4, is known as methane. 2 carbons, or 2-carbon chain, is ethane. 3 carbons is propane. 4 carbons is butane. 5 carbons is pentane. These hopefully ring a bell since they were included in the video that we had previously on Introduction to Functional Groups. 6 carbons is hexane. 7 carbons is heptane. 8 carbons is octane. 9 carbons is nonane, and 10 carbons is decane. All right, and so those are things that we need to know, because when we are picking out the longest chain, we need to be able to give it a name, and the names are always going to be the same. So when we are naming a compound, step 1, and this is step 104, is to locate the main chain. And again, the main chain of the organic molecule is the longest continuous carbon chain that includes the highest priority functional group. We'll get into functional groups when we name alcohols, which will be our first functional group. But for today, it is just to locate the longest continuous carbon chain. So note that the little thing sticking off of the side here, there is 1 more carbon. That is not part of the main chain. It is not part of the continuous carbon. So that is a 7th carbon, but it is not directly in the row. All right, so that is step number 1. Step number 2 is to number the main chain. And the way that we always number the main chain, well, first off, think about it. We only have 2 options. We can go, in this case, from left to right, 1, 2, 3, 4, 5, 6, or from right to left, 1, 2, 3, 4, 5, 6. Either way, it's a 6-carbon chain. But what we want to do for this, because there will always be a tie in terms of the length, is to number it starting on the side with the closest possible substituent. So for instance, if we number it from the left, you'll notice that we would have a substituent or a group coming off of the third carbon. If we number it from the right, we would have a substituent coming off of the fourth carbon. So essentially, you're trying to minimize your numbers as much as you can. So let's number this, in which we should do left to right in this case. 1, 2, 3, 4, 5, and 6. And we do that left to right again because the closest substituent, or the only substituent in this case, is closest to the left side instead of the right. Therefore, if we start numbering on the left, that little group would be on carbon number 3 instead of carbon number 4, which makes the number as low as possible. So at this point, what we could say is that we know that this is a 6 carbon chain. Therefore, this molecule is indeed a hexane. And when we get into the final naming, that will be the main part of our naming for this molecule. It is a hexane because the main chain is 6 carbons long. So let's try one more example really quickly, and this will be the one that we proceed with. The one up there is quite simple. Let me do this. All right. So if you like, you can pause and see if you can find the longest continuous carbon chain in this one, but I'm going to go right through with it. When we look at this guy, we have a whole lot of stuff in this molecule, but the longest chain would actually be starting over here or over here. Either one is the same. And going this way would be 5. 1, 2, 3, 4, 5. Going down would be 1, 2, 3, 4, 5. But going down into the left, 1, 2, 3, 4, 5, 6 would give us a 6 carbon chain. Therefore, in this molecule, the main chain would be these 6 carbons. When I want to number it, I can start from the left or the bottom. If I start from the left, the closest substituent would be at carbon number 1, 2. So I'd have something at 2, 3, and 4. If I started at the bottom, it would be at 1, 2, 3, 4, 5. So I'd have something at 3 and 4 and 5 if I start at the bottom. I'd have something at 2, 3, and 4 if I started on the left. So 2 is lower than 3, therefore I would start at the left, and this would be 1, 2, 3, 4, 5, 6. This is also a hexane because the main chain is 6 carbons long, but it is a slightly more complicated one, so this is the one we'll use to proceed through our naming examples. I want to add in a couple quick notes here. The first is to let you know, if you didn't recognize this, that the names of all of our main chains really just start with the word alkane. Just like adding in a functional group, we'll always be finding our main carbon chain, and so the carbon chains are the backbones of it. Similarly, with the names, the word alkane is the backbone of everything. So notice that in terms of everything we have written here, what we have modified is this part alk. Alk in alkane has been changed to meth to make it methane, or eth for ethane. So we're always going to start with the word alkane and modify selective parts of it when we're doing something. The second thing I want to note is that sometimes you'll have a tie for the main chain. So this is something that usually comes up eventually, but I want to just get it out of the way right now. So if I have a molecule that looks like this, there are a lot of different ways to get a 5-carbon main chain, and they're not going to be exactly the same. So I will draw this twice and tell you that there are 2 different ways that you can get 5 carbons, 2 main ways. One is to go left to right, and that would be 5 carbons. The other would be to go from left to bottom. You could also go bottom to right, but that would end up being symmetrically the exact same thing as that bottom situation. So notice that they are not the same. In one of those, it has what kind of looks like just one single chicken foot coming off of it, and down here we actually have 3 different groups coming off of it. The way that you would break this tie is that if you have multiple main chains that are the same distance, you want to use the one on the bottom. You want to use the one that has the most substituents. And the reason for that is the more substituents you have, the simpler they are. The less substituents you have, the more complicated they are. So that one on the top would be incorrect. We would not name it this way. Instead, we would go with this one on the bottom. Again, if you have a tie, you want to choose the main chain that has the most direct substituents. All right, let's see how you can do on this, and then we'll move into step number 3. So once we've been able to locate and number our main chain, the next step, which will be step number 3, is to name our substituents. And our substituents are any groups that are not part of the main chain. So they are substituted onto the main chain or coming off of the main chain. So going back to the molecule that we previously drew, I'll put it back out here again, our example. And we will recircle the main chain. You probably just have it drawn in front of you, so you don't need to redraw and recircle it, and that's fine. And I will renumber it as well, so we have it over here. 3, 4, 5, and 6. Okay, so what we can see is that we have substituents coming off of this, which are right here. That carbon is not included in the main chain. This little 2-carbon branch is not included in the main chain. And this little 1-carbon branch is also not included in the main chain. So these are not part of the main chain. They're instead things that are coming off of the main chain. Think of these as adjectives. They are something that is attached to whatever you have. So let's talk about how to name those. Just as a 1-carbon main chain is a methane, a 1-carbon substituent is called a methyl group. So if you have a CH3 coming off of something, it is called a methyl. I should stop and mention that R is the kind of like X is used in algebra as an unknown or just some group. R is used in organic chemistry to mean some alkane. So if I have some alkane main chain with a CH3 coming off of it, that CH3 is called a methyl group. You will probably notice at this point that we have a methyl group right here. It's just a CH3 or a 1-carbon substituent. We also have one right there. A 2-carbon substituent would be called an ethyl group, similar to how a 2-carbon main chain is called an ethane. All right. When you have 3 carbons, you have a couple different options. So what I'm going to do right here now is pause and say an R with a 1-carbon looks like this. An R with a 2-carbon would look like that in terms of line angle. Well, if you have 3 carbons, it could look like this, 1, 2, 3, and we might say that this is R attached to CH2, CH2, CH3, and probably not as any surprise to you, since a 3-carbon main chain is called propane, this would be called propyl. All right, but there's another way to have a 3-carbon chain attached. Instead of essentially attaching it at the end, you could attach it in the middle of those 3 carbons, and it would look like this. This is an isopropyl group. So again, you can see that these 3 carbons right here are just in a row. These 3 carbons are in a row, but they are attached to the R group at the middle one. So it kind of looks like a little split end coming off of there. And as a condensed formula, this would be R attached to a CH with 2 CH3s attached, which we could write out like this, or you could write R attached to CH, and then CH3 in parentheses 2. Any of those are correct. This is called an isopropyl group. Iso is short for isomer, so an isopropyl is the isomer of a propyl group. Isomer meaning something similar with the same number of carbons and hydrogens, but arranged in a different way. All right, when we get to butyl, there are 4 different possibilities, and these you need to know. You need to memorize the names of all of these. So 1, 2, 3, 4. A straight 4-carbon chain coming off of this is the quote-unquote normal version. So this is just called butyl, or sometimes is called N-butyl, that is to say normal butyl. Oftentimes that N is left off, but I'll put it on there anyway. You can include it or not include it, and either way is fine. All right, so going back to what we did previously, the isopropyl is the one with the split end, or that little fork right at the very end. And likewise, there is an isobutyl, which would include 1, 2, 3, 4 carbons with that little split end down there. Notice that it is bigger than an isopropyl group because there are 4 carbons instead of 3, but it still has that characteristic split end at the very end. This is called an isobutyl group. All right, there are 2 more that you need to know. One of them looks like this, and one of them looks like this. This guy on the top is called a sec-butyl, and this guy on the bottom is called tert-butyl. And there is a really good reason for that, and if you remember, ask me in class and I will explain it to you where the sec and the tert come from. All right, so going back to our example at this point, you'll notice that we have this little group at the top coming off of here. That is simply a methyl group, and I'm going to be specific and say that that is a methyl group coming off of the carbon number 2. Therefore, that would be a 2-methyl. This second group coming off of carbon number 3 has 2 carbons, therefore it would be called a 3-ethyl. Again, 3 because it's coming off of number 3 in the main chain, ethyl because it has 2 carbons. Coming off of carbon number 4, we have another methyl group, so this would be a 4-methyl group. What you'll find is most substituents are relatively small because most of the carbons in the molecule are included in the main chain normally. Sometimes they get more complicated, but you'll be able to do that as well. So you can imagine once we get to pentyl or hexyl or decyl that we have a lot of options. There could be many, many. And there are kind of these common names that you could memorize for all of the different possible 10-carbon substituents, but I don't have them memorized. I certainly can only imagine that there are hundreds, if not thousands of them. Therefore, we're not going to worry about that. But these are the common ones that you'll see: methyl ethyl propyl, isopropyl, and then the 4 different versions of butyl. So let's give this a try, and then we'll move on to step number 4. Step number 4, as you can imagine, is just putting it all together. And I will call this name assembly, or you could say putting it all together, or whatever you want. All right, so basically what we're doing is we're taking our little bits and putting them together. We have parts of a name, and so we'll assemble it into just one name. So this was our molecule, again drawn out, and I will circle the main chain, and we will number the main chain, 1, 2, 3, 4, 5, 6, and we said that we had a 2-methyl, and we have a 3-ethyl, and we have a 4-methyl. All right, so when we assemble these guys, what we need to do is we need to combine any similar terms. So for example, I have 2 different methyl groups, and I can put those together and say that there's 2 methyls, or what we do is dimethyl. So di is a prefix you use if there are 2. Tri you would use if there are 3. Tetra you would use if there are 4, etc., etc. So di is if there's 2 of the same thing, tri if there are 3 of the same thing, tetra if there are 4 of the same thing. We don't usually get to that, but there could be a penta or a hexa, etc., etc. So what we would do in this case is say that I have, instead of 2-methyl and 4-methyl, I have 2, 4 dimethyl. And that indicates that there are 2 methyl groups, one of them at carbon number 2 and one of them at carbon number 4. We only have 1 ethyl group, so we don't need to say di or tri or even mono. We would just say that we have a 3-ethyl group. These are the substituents that come first, and if you recall, all of these are attached to the main chain, and the main chain is called hexane. So hexane would go at the end. All right, so the way that this has been organized is that the main chain goes at the end in terms of the name, and all of the substituents are arranged in front. All right, you may have noticed that I put those in a specific order, but the substituents are arranged alphabetically in terms of what exactly they are. So ethyl would come before methyl simply because E comes before M in the alphabet. I realize that this is a di, but we do not include the di or the tri or even tert or sec or anything like that in the arrangement of our alphabetized substituents. So I will note that on here that these are arranged alphabetically. Ignoring prefixes. All right, there is an asterisk to this. There are a couple rules of IUPAC that I would like to apologize for because it's been made, the system was designed in order to be as logical as possible. However, there's a couple things that I don't quite love. And two of those things are that there are two prefixes that we do not ignore. Iso is not ignored, and cyclo, these guys are not ignored. That is to say, they are included in alphabetization. All right, and that is how you name a molecule. You might notice that I put some dashes in there. Basically what we do is anytime we go back and forth between numbers and letters, we use a little dash in between. So there's a dash here between the 3 and the E, a dash between the L and the 2, another dash between the 4 and the D, and then we don't have any dashes anywhere else or any spaces anywhere. All right, so what I'm going to do is go through one more example with you, and then I will give you some questions. All right, so I'm going to give you another example here, and we will go with this guy. Doot, 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 doot. Doot, 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 doot. Doot, doot. All right, so this is a lot of carbons, but step number one is we need to find our main chain. Our main chain will be the longest continuous carbon chain, and quite obviously the left side of it needs to be included. Hopefully you can see that because this part here is so long. So if we go from the left, it could be 1, 2, 3, 4, 5, 6, 7 if we go left to top. It could be 1, 2, 3, 4, 5, 6, 7 if we go left to right. But notice that there's this big chunk down here, and we can twist down this way. If we go starting at the left, 1, 2, 3, 4, 5, 6, 7, 8, that would give us our longest main chain. So our main chain is going to do this. It's going to veer down there. All right, we want to number it, so step number 2 is that we want to number this guy. And we want to number starting at the side closest to the first substituent. If we start on the left, our first substituent is quite a ways away, but if we start at the bottom, our first substituent is actually on carbon number 2. So 1, 2, 3, 4, 5, 6, 7, 8. All right. And so right off the bat, I can say that in the end, my name of my molecule will be an octane. All right, so let's do what's next. All right, step 3, we're going to name our substituents. Got one there, one here, one there, and one there. So let's do these one at a time. I have a 2-methyl right here. I have another 2-methyl over here. So there's 2 methyl groups coming off of carbon number 2. There's a 3-methyl right here. And there is a 4-ethyl up at the top. Again, the numbers indicate where they are coming off of. All right, and now I just need to arrange this. Well, ethyl comes before methyl, so I have a 4-ethyl. And then I have 3 methyl groups. I have a trimethyl. Therefore, I need to put 3 numbers out there. I need to say that I have one at 2, another one at 2, and then one at 3. So I have a 2, 2, 3 trimethyl. And that's all our substituents, and our main chain is octane. So I don't know if I can move this up. Oh, I can only move the whole thing. Well, that's unfortunate. I will just write it again. octane. And that is the name of the molecule. So see how you can do. Bring any questions to class, and we will definitely practice this. Have a good day.